Let's study the structural system of a wholesale store. This one is located somewhere in Bangkok. I took its pictures when I was there doing some grocery. The roof of the building is in structural steel. The columns are in reinforced concrete. Let's get on with it. I will express my observations about the structural framing of the building. I will discuss two important connection details, one over the columns and one at the intersection of beams and girders. I will also talk about the framing adopted at the braced base. And I will talk about the structural framing of the roof in general as well. Let's start with the load transfer first. The gravity loads are transferred via the same members which are normally used in steel roof, that is purlins, and purlins are braced against sideway with other members as well. The purlins transfer the load to the continuous beams. Continuous beams transfer the load either to the columns or to the girders, which are simply supported, and these in turn transfer the loads to columns which take it to the foundation. There are three braced base in the roof in the east-west direction. I was not able to take pictures of the braced base in the end walls. A load transfer in the north-south direction is through the frame action. You will get to know about these in the upcoming slides. This is not the complete roof framing plan. This drawing shows the conceptual framing of the roof only. You can see that there is a lateral support of purlins in the form of channel section. Purlins itself have channel sections as well. Beam and girders have I or W section, and RC columns have a square section. In the braced bay, there is a strut as well. Strut has a circular cross section, probably a circular tube, and the braced base, in the braced base, the bracing is done with the standard rods. In east-west direction, the load transfer is via braced bay, of course, and in the north-south direction, the building depends upon the frame action provided by the continuous girders and their connection to the RC columns. We will get into the detail in the upcoming slides. This picture shows what was diagrammically depicted in the earlier slide. You can see here that these are purlins which take the load from the roof and transfer to these continuous beams. You can see that these beams are continuous over columns, and these beams are also continuous over these girders as well. You can't see here, but you will be able to see in the next slides that these green beams run over these blue girders as well. You can also notice that the purlins are braced against side movements through these small channel section, which increase their movement capacity in their principal planes. Otherwise, they can be subject to lateral torsional buckling. Now let's move on. One other thing to note here in these continuous beams is that there are three movement connections in each bay. If I don't know if you are able to see it or not, but let me draw your attention to location over here, and over here. These are the locations where these continuous beams are provided with movement connection in a single span, and there are these three movement connections in each of these spans, and the movement connection consists of end plates, extended end plates with about 8 to 10 bolts. Okay, in this picture you can note that every girder has an end plate movement connection at approximately the center of the span. Take a look at these additional braces for flanges at the connections as well. You can also notice the web stiffeners as well. You can see that the braced bay of the roof as well, but you can't see it clearly. See here, this is the beam to girder connection. Here there is a beam to column connection. You can see that the continuous beam has been supported to resist the lateral torsional buckling. Their flanges have been braced. You can see that the flanges of girder are also braced at this beam to girder connection, and this is the braced bay. You might be able to see these cross bracings here. There's a cross bracing here as well, and there's a cross bracing here as well, and similarly it runs in this direction as well. Let's move on and see what else we got here. Yeah, this picture shows a closer look at the braced bay. You can see that there is a strut for each cross bracing, and there are about 3 cross braces in each bay in north-south direction. So this is the north-south direction, and this is the strut that I'm talking about. There is a strut here, there is a strut here, there is a strut here, and this is one simply supported girder, this is another simply supported girder, and you can see that there are 3 cross bracings in one bay, and this cross bracing runs from continuous beam to continuous beam, and this is the continuous beam that I'm talking about. This is one continuous beam, this is another continuous beam hidden by this AC duct, and that's how the braced bay of the roof framing looks like. There's probably a strut here as well, and similarly the bracing keeps going in this direction as well, and there are about 3, I think 3 braced bays in this entire roof. One is here, one is on the left end, and one is on the right end. This one is somewhere in the middle of the roof framing. Yeah, this picture shows was taken to clarify the beam to girder connection over here. You can see that girder has an end plate movement connection at about mid span. There is also a flange brace for girder. There is a flange brace for the beam at this location as well. And you can also notice that there are web stiffeners in girder. There are also web stiffeners in beam, but you can't notice it here from this picture. This is flange brace for girder, and this is flange brace for beam. This is the web stiffener that I'm talking about. This is the web stiffness in the girder. There is a web stiffener here as well, but you can't see it, and you can see that the girder has an extended end plate movement connection at about center span, and it has about 12 bolts. You can also notice here that The continuous beam has been provided with flange braces throughout its span so that it can give its moment capacity along its major axis to its fullest ability. Let's move on. Okay, this picture over here shows, it's not a picture, it's a diagram drawn by me, and the diagram shows the girder to beam connection, which I shown in the previous diagram, and it comes up here as well. You can see that this stiffener over here is right there, and this end weight collection is right over here. Similarly, this is the flange brace for the beam, which is over here. This is one flange brace, and the one flange brace runs in the other direction as well. This is the flange brace for the girder, which is not shown here because it's out of the plan. And this red member is a bearing plate between the girder and the beam. You can't see it here. That's pretty much how this connection looks like. I hope this diagram over here, beam to girder connection diagram over here, clarifies what is being constructed. Let's move on. Okay, I have added two further diagrams. These diagrams show the beam to column connection. This is also a very important part of this structure because it provides a load transfer path in the north-south direction via the rigid connection at beam and column joint assembly. You can see here that the girder and the beam has a shear connection. There are about 8 bolts for the shear connection, but for the beam it's a moment connection. There are no bolts here. The beam simply goes continuous over the column as shown here, and the two web stiffeners are provided in the beam to transfer the point load. You can see that they have also used a I or W shaped stub between the bottom flange of the beam and top of RC column. Stub has an extended plate moment connection with the beam. The girder, as I've discussed earlier, has a shear connection at this location with 8 bolts. This stub over here, this I-shaped stub over here, this stub also has a moment connection with RC column, and there is a grout pad between the stub and the RC column, and this stub also has a base plate as well, which probably has 4 or 6 bolts. I can't see it here, but it must have, because I can see these 2 bolts over here. These 2 bolts are connecting the top end of stub with the bottom flange of the beam, and there are at least 4 bolts because 2 are shown here. We can see 2 here, and there are most probably 2 on the other side as well. This picture, this slide over here shows all the connection details that I discussed earlier. I hope it clarifies what is being constructed at the site. You can see the detail of the RC column and the continuous beam connection, as well as the girder to beam connection here. You can refer back to the earlier pictures and relate to what is being drawn here for better understanding. One thing that I missed earlier is that you can see that there is a web stiffener at the location where the flange brace of beam connects with the girder. That's a nice detail. It basically transfers this small point load into the web without having to fear about the buckling of the web of the simply supported girder. These are the details not related to this particular building. If anybody is interested, the one on the left is shows expansion joint for RC pavement. The one on the right is a classic pin connection to anchor and uplifting force. The joint of RC pavement, which allows expansion, can also transfer the V load across the joint. That's why it has been detailed like that. Thanks for watching. I hope you understood the structural framing adopted for this building, as well as the important connection details adopted for this building to transfer and the forces. See you.